Hello, and welcome to the video portion for the Reference Geometry Lab of ME 123. More specifically, we will be focusing on reference planes, including how to use planes, how to produce reference planes, and some new uses of the extrude feature that make the most out of our new reference planes. We will also briefly mention reference points and reference axes. Then we're going to wrap up with a brief discussion on coordinate systems.
Let's start with how to make the most out of the planes that we already have. As you're aware, each SolidWorks part file comes with three predefined planes: our front plane, our top plane, and our right plane. If we're clever with how we set up our first extrude, we can get more usage out of our initial planes. For example, let's model a cube. I'm going to start up a new sketch on our top plane, and we'll use the point rectangle tool to draw a square with one of the corners on the origin. To fully define our shape, we're going to add an equals relation to enforce the squareness, and use a smart dimension to set the side length equal to 50 units. Next up, we can go over to the Features tab and select the Extrude Boss Base, and set the extrude distance to 50 units to match up with the side lengths. By setting up our extrude like this, we have 6 unique surfaces, one for each face of the cube. As you can see, our front, top, and right planes are all coplanar with the cube surfaces, meaning that they're effectively describing the same planes. We can also see that whenever we start a new sketch, our origin is set in the corner. Let's make this a little bit better. We're going to go in and edit the sketch that we used to create our first extrude, but this time, instead of using the point rectangle, we're going to use the center rectangle. To find the center point on the origin, reapply our equals relation and our smart dimension to set the side length to 50 units. And now when we exit our sketch, we can see that we have 8 unique surfaces. We still have the 6 from the cube, but now the front plane and the right plane bisect the cube, giving us the 2 new unique surfaces. In addition to this, if we were to open a sketch on the top or bottom surface of the cube, we can see that the origin is now centered instead of being in the corner. Let's do one better. By modifying our extrude's end condition to change it from blind to midplane, we freed up the top plane as well, giving us a total of 9 unique surfaces that we can use for sketching, for starting and ending conditions, or for other future tools. As an added bonus, no matter which surface we open a new sketch on, the origin is going to be right in the middle, which can give us some nice references for future usage. The moral of this story is that properly setting up your initial sketch and being clever with the end conditions for your first feature can give you more usage out of the things that we already have. Alright, now with that out of the way, we can get to the meat of today's topic: reference planes. A reference plane gives you a new plane that can be used the same way as one of the 3 primary planes. You can sketch on them, you can use them as starting and ending conditions. They're fairly useful tools. Let's start with how to make a reference plane. First off, a reference plane needs to be based off of something. Let's continue using our cube. Once we've exited our sketch, we can access the reference plane by going to the Features tab, hitting the drop-down below Reference Geometry, and selecting Plane. Here we can see that we have 3 boxes for references. There are lots of ways to define a plane, with a complete list of combinations available in the lab chapter. The easiest one is the offset normal plane. As a quick aside, a normal surface is visible as a surface in one view, and it shows up as a horizontal or vertical line in the other 2 views. With the first reference box selected, we can choose the top face of our cube and take a look at the menu. We have several options to pick from. I'm going to use the offset distance option, and then we can type in the offset that we want. Let's go 30 units up. This creates a plane that is parallel to one of our pre-existing surfaces, which often is not entirely necessary. With extrude, we can use the offset starting condition to get a distance between the sketch plane and where the feature begins. I recommend considering if there would be a more compact way to produce the feature that you want without creating a reference plane. Having too many reference features can really clutter up a SolidWorks part, making it difficult to edit in the future. One other thing to note is that you don't need to create a new reference plane whenever you need a new sketch. If you've already got a plane that would have been along the same plane as another flat surface, you can use that surface. Another common type of plane is the inclined plane. An inclined surface is a surface that is visible as a surface in 2 views, and it shows up as a diagonal line in the 3rd view. First, we're going to need to open up our reference plane again. First, we have to give it a 0 plane, or the plane that our angle would be measured from. Next up, we have to give it an axis that will be rotated about. Here we can choose a sketch edge, a reference axis, or just about any straight edge that we could select. Finally, we need to tell it the angle that we want. We're going to select the at angle option, and then type in our value. Let's do 30 degrees. That looks good. We can hit our green checkbox up at the top to finalize the feature, and now we have our inclined reference plane. Let's take a quick break from making new reference features for a minute and consider what we can do with these things. Let's start by creating a new sketch on the top surface of our cube. How about a circle that we center in at our origin, and draw it out to have a diameter of 25 units. From here, we can go back over to our Features tab, Extrude Boss Base, but instead of using the blind end condition, we're going to use the up to surface and select Plane 2 as our ending condition. We can see here that this allows us to get this interesting sloped surface at the end of our cylinder. One thing that you need to consider is which surface we want to use as our sketch surface. This time, let's create a new sketch on the reference plane. The first thing that we can notice is that our origin is in a kind of strange position. SolidWorks always projects the same origin point onto whichever surface you're working on. This can lead to some issues if you're not looking directly at the sketch. While you are not normal to the sketch, selecting the origin can be a bit of a challenge. If you're having trouble with this, you can choose the origin from the design tree and use it from there. Another quirk is how the Convert Entities sketch tool functions when working on a plane that's not parallel to the entities that you're converting. Similar to the origin, these entities are going to be projected onto the current sketch plane, leaving them distorted. Anyway, back to the point, we can start a sketch on this reference plane. Let's do another circle centered on the origin, give this one a diameter of 10 units, and then bopping back over to Features to extrude it so that it goes up to surface, and selecting the top surface of our cube as the end condition. When we take a look at it from the side, we can see that it's extruded the cylinder at a specific angle. The extrude feature always extrudes orthogonal to the sketch plane, or in the direction of the normal vector of the surface that we're working on. This is important to remember when starting your sketches to make sure that the resulting features turn out the way that you expect. So, that covers several ways that we can create and use reference planes. What other methods can we use? A common one is to define a plane using 3 points. Here, we're going to need to define our 3 points for the plane first. We can create new sketches on any of the flat surfaces and use the Sketch Point tool to define our points. I'm going to create this sketch on the top surface, and here we're going to define our points so that we have one of them along the top edge of the cube and one of them on the right side. We can see that SolidWorks has automatically applied some coincident relations for us to hold the points onto the edges, so all that we need to do is apply some smart dimensions to properly distance them from the corner. In this case, this one's going to be 15 units down, and the second one is going to be 20 units to the left. Now that this sketch is fully defined, we can exit the sketch, open up a new sketch, this time on the right surface of the cube, and we'll draw on our final sketch point, setting it along this edge here, and defining it to be 10 units down from the top. It's important that we use the dimensions the way that they're given, and that we avoid repetition. Now that we have our 3 points fully defined, we can exit our last sketch, and go back up to the reference geometry plane to begin creating our reference plane. From here, we can select the 3 points that we've drawn as the 3 references for the plane feature, and hit our green checkbox to create the plane. Reference planes can use anything that defines a point, so you can also select vertices and endpoints of sketch entities to define your reference plane. Okay, now that we have our plane drawn in, I want to use it to remove this portion of the cube. The first thing that comes to mind is that we could draw some kind of shape on the reference plane itself, and then use the extrude cut to get rid of the corner. This, however, doesn't always work as well as you would like, so I'm going to use an alternative approach. Instead, I'm going to start sketching on this flat surface here, and then we're going to begin by sketching out the outline of the piece that we want to remove by using the 3 reference points that we had created. From here, we can go back over to Features, Extrude Cut, and set it so that our ending condition is up to surface, choosing the oblique surface that we had just created. This will cleanly cut the corner from the cube, while only affecting the material on this side of the reference plane. This 3-point trick that I showed you shows up fairly frequently, so I would recommend keeping it in mind. Let's go over a few more common plane types that show up for this course. Tangent planes show up when you're trying to connect a plane to a curved surface. Here, we'll make a plane that's tangent to this cylinder and parallel to one of the faces on the cube. Normal also shows up fairly frequently, and it really becomes important later on when we cover sweeps. You can select any edge or line, curved or otherwise, and then any point along that edge. This produces a plane with a normal vector that's parallel to the tangent vector of the line that intersects the edge at the given point. The parallel plane also shows up fairly frequently. It works similar to the offset plane, in that first you need to select a surface, but this time instead of typing in an offset distance, we can select a point, and the parallel plane makes sure that the plane crosses through that point, while remaining parallel to the surface. Lastly, let's see what can be done with reference points and reference axes. There are a few ways that you can define a reference point, but one of my favorites is center of face. I recommend that you explore the other options yourself. Center of face just plops a point right in the middle of whichever surface you select. From here we can hit our green checkbox to place the point, and then we can move on to reference axes. You can choose from a variety of options here, but for this circumstance we're going to use point and face/plane, which is going to draw an axis that is parallel to the face's normal vector, but it crosses through the point that we've selected. Similar to planes, reference axes are also considered infinite, so the exact location of the axis in space is not as important. Of note, both of these pieces of reference geometry show up as blue. This does not mean that they are underdefined. SolidWorks does not let you create underdefined reference geometry. Anyway, now that we have our axis, let's use it to create an inclined reference plane. I'm going to open up the reference plane menu, select our axis as the first reference, choose this face to be our 0, and then set our angle, 20 for this one. Some of you may have noticed that there are some other ways that we could have made this plane, while using all of the same information. Instead of going through the trouble of reference points and axes, we could have just made a horizontal construction line on the front plane that passes through the origin. There are very few cases where reference points or axes will be absolutely necessary to create geometry, but there are some occasions where these tools can save you some work.
Now, before we let you go, the 2022 update for SolidWorks has improved the functionality of reference coordinate systems. So let's take a minute to show how to make these and what you can use them for. We've technically already been using a coordinate system with our origin, primary planes, and principal axes. However, that's locked to a single place, and with more complex models, it can be useful to create a new coordinate system to reset our orientation and to give us a fresh set of planes and axes to use. This makes coordinate systems very powerful tools with a lot of options and use cases. But we're going to focus on one of the simpler applications for now. On occasion, you'll want to be able to set up a plane that is both offset from a given point and set at some angle from a given surface. With standard reference planes, you'll often need to chain multiple planes and/or create sketches to define offsets and axes of rotation. However, with a coordinate system, we can do both of these simultaneously. Let's start where we left off with our previous model, but now I want to use this triangular sketch to produce a cutout that goes into the model some distance, then stops at some inclined plane. There are a lot of ways that we could produce this geometry, but for now, let's use a coordinate system. You can find coordinate systems under the reference geometry dropdown right here. I want the middle of our hole to end about 10 units further in than our origin. So we're going to check this define position with numerical values box and type in a -10 for our z direction. We can tell which one of these x, y, and z we want to modify by using the triad in the bottom left corner. Additionally, I want our reference coordinate system to be at a 20-degree angle pointed downwards. So in order to set that up, we can check this define rotations with numeric values box and plug in 20 degrees for our x-axis. Remember that we can always reference the triad in the bottom left corner to confirm which axis is which and to determine our positive directions. Angles and position values when using coordinate systems are always with respect to those three directions, with angles being measured counterclockwise when looking directly down the axis, and positive positional values being in the directions that the arrows are pointing. We could also set up a coordinate system by choosing a point that would be our origin, and selecting lines or edges to define the directions of our axes. But in this case, we're defining everything purely numerically. Now that we have our numbers plugged in, we can hit the check mark to finalize, and pop over to the Features tab to select Extruded Cut so that we can begin creating the feature. I'm going to select our sketch as the input, and then for direction 1, we will set this to up to surface, and then choose this angle here between the y and the x axes to select the xy plane on our coordinate system. We can hit the check mark to finalize our feature, and then if we orbit around, we can see that it did remove the material inside of our object. To get a better look at our ending condition, we can use the Section View button up here and set this to our right plane using one of these three buttons to get a look at the inside. We can see that this cut does indeed end in an inclined surface, meaning that our coordinate system has done its job. We can hit our X up here to exit out of the section view, and we completed our little part. As mentioned earlier, reference geometry can really clutter your part when you have a lot of it in one model. Likewise, sometimes reference geometry can be hidden from view, leaving you unable to use it. You can hide and show individual pieces of reference geometry by right-clicking on them in the design tree or in the view window and selecting the Hide button or the Show button. To hide or show all visible sketches and pieces of reference geometry, you can select this Hide All Types button up at the top. Similarly, if you can't see any of those things, you can select it once more to get them back. Lastly, for more granular control, you can hit this downwards triangle next to the Hide and Show button to pick and choose different types of things that you could see or have hidden. So, this about covers everything that I wanted to talk about for this lab. There are a lot of tricks that you can pick up with reference geometry, So as always, experiment. Have a good day. We'll see you again next time.